Hello, good morning or afternoon, whenever you're watching this. So my name is Mr. Palacios, and you're hearing me right now. It's because you have started uh, our course on geometry, which is a 5-week course. Uh, a couple things have changed about this course because we're only doing it for 5 weeks. So right here, I have a breakdown of some of the changes you should expect. So feel free to write this information down because it is kind of important. If not, just feel free to pay attention while I read off these announcements. Okay, so this geometry class will be based on a 5-week system. This means that you'll have to work every day, Monday through Thursday. What that means is I will be releasing work every single day. For example, on Monday, right, you can expect a warm up, right, that it's due that day. So whatever day something is posted, that's essentially when it's due when it comes to the warm ups. The warm-up will usually be a question about either the lesson, definitions, any variety of things that have to do. Most of the information will be found within the video. Every week, you're going to have a video that's uploaded on Monday so that you guys can digest the material, talk to your teachers who are on site. Right? I know this is a new system we're trying out, so just be patient with us. All right. So, with that said, Monday, you'll start off your day with the warm-up. Then you will watch the video and you will take notes. All this is done on Google Classroom. So the link to the video will be posted on there. You'll watch it, you'll take notes on a separate piece of paper, and you'll upload those notes for points. That is essentially on Monday. The sooner you get those lesson video notes up, the better. Um, you technically have until the end of the week to do the lesson video notes because I'm trying to give you as much time as possible to turn everything in. However, uh, doing them that Monday, especially if you're at your school site, watch the video, take notes down, and do the warm up, and then that's your work for Monday. Tuesday, you'll have another warm up posted, and you'll have practice problems for concept one uploaded on there, right? What that means is I'm going to be breaking up different concepts. So because we only have 5 weeks, we're going to have to cover a little bit more material per week than we normally would. Right. So that means you're going to be doing problems every single day, uh, a single page of work every single day, something that it's going to eventually come down to. Right here, I just say practice problems for concept one. Every week, the concept one could change. It could be one thing. For this week, at least for geometry, it's going to be complementary angles, right? And concept two will be supplementary angles. We'll go into that into the rest of this video, right? Uh, but the practice problems for those will be posted that day. And again, the practice problems themselves are going to be due by the end of the week. However, the warm up is going to be due the day that it's posted. So every day you need to be checking in, even if you're not at your school site. It's important to check in, do the warm up. That doesn't mean that you're necessarily present for the day. Um, Attendance is based off of whether you're actually showing up, from what I understand. But still, this is the work that's expected if you show up. Uh, so just so you know what you need, every day you'll have something new that you need to do. And if you didn't finish something you did last time, then you're gonna have to, it's gonna start piling on. So this is gonna be a very quick paced system and you're just gonna have to keep up. So Thursday, there'll be a warm up and then there'll be advanced practice problems. This is going to be usually a combination of concept one and two. Depending on what we're covering that week, they could be two concepts that are loosely related. They could be two concepts that are very related. For example, for this week, complementary and supplementary angles and equations are very related. They're interrelated. Um, they depend on each other, which means that for Thursday's work, the final practice problems are going to be harder, but they're going to use everything you've learned from the previous days, right? And it's a kind of progression thing that we build out throughout the week. However, you shouldn't wait until the last minute to do any of this because these kind of things will add up. And if you turn things in late, there is a late policy where because there's only 5 weeks, if you turn something in late, past its due date, um, you won't get credit for it. There is an exception for the first week. However, every week after that, you either turn it in before or on the deadline, or you don't get credit anymore. And then since it's only 5 weeks, it'll pass by really, really fast. Okay. So, with that in mind, there's a note about Zoom. Zoom is a tool used for clarifying questions if I'm not physically at your school site. So the question, do you have to log into Zoom? Not if I'm at your school site. If I'm at your school site for whatever reason, and I'm there helping you one-on-one, then you obviously don't need to do anything with Zoom because I'm there, I'm helping you, you're getting one-on-one help with the material anyways. However, if I am not currently at your school site and you're getting help from another teacher, right, and then both of you are kind of stuck and you want to talk to me because I'm in a different site, you can always go onto Zoom. The Zoom link will be in the Google Classroom, and then I'll try to make it so that that I can be on there whenever I need to be on there. So just so you know. Okay, with that all said, let's get started with the lesson. Okay, so first thing I want you guys to write down is I want you guys to write down your definitions. Uh, every video will begin like this, right? The definitions, feel free to pause the video if you need to copy these down. The definitions, you need to know what angles are. Angle is a figure formed by two rays. So what do I mean by that? Well, if you remember seeing things like this in the past, these are angles, right? Angles are basically made up of two lines that connect at a vertex, and the vertex is right here. It's basically the point in which two lines meet, right? These are all what we'd call angles, right? We'd call these angles, and that's all it is. You're going to be studying angles. You're going to be doing things with angles. You're going to see the word angles a lot. Um, Complementary and supplementary angles are different types of angles, right? So in this case, complementary angles are two angles. Two angles are complementary when they add up to 90 degrees. A right angle. What I just circled is a right angle. Again, hopefully you're writing these definitions down, but you are going to have to memorize these and use them throughout this week. Um, they are also, there's a note here that says they don't have to be next to each other so long as the total is 90 degrees. Now, what I mean by that is, let's say I have an angle like this, right? Um, let's say this angle is 45 degrees. And, there's a bunch of other angles here, and none of them add up to 90 degrees because, they don't. But then there's another line here, right? And this line has another angle that's 45 degrees. Well, if we add angle 1 and angle 2 together, measure angle 1 plus measure angle 2, we end up getting 90 degrees, which is the definition of a complementary angle. We can say that measure angle 1 is a complement to measure angle 2. Or if we wanted to, we could also say that measure angle 1 and measure angle 2 are complementary, right? You are going to have to identify these and be able to figure them out. Like I said, they don't have to be right next to each other. Usually they will be, though. So just keep that in mind. They don't have to be next to each other. They could be on different lines. But as the key here is, as long as two angles add up to equal 90, they're complementary. Same thing with supplementary angles. Two angles that when you try to add them up, they're going to end up being 180 degrees this time. Now, if a right angle is 180 degrees, 90 degrees, 180 ends up looking like a line. And it has to be specifically a straight line. Okay, so what do I mean by that? Let's go on to the next page to find out. So here, this is a much neater way of showing you what I just showed you earlier, right? The difference between straight, acute, obtuse, and right. Notice I'm introducing a couple more pieces of vocabulary, right? I want you guys to write these down as well because these are important. You are going to have to identify these different types of angles. When we don't know the exact, what's it called? The exact degree of each angle, we're still we still have to find a way to classify them. Right here, I have degrees on all of these angles. However, if you look at the definitions, if you look here, right, like for straight angles, look at what I wrote here. Straight angles are essentially straight lines. And if you are physically to measure a straight angle, it will always be 180 degrees. The rule for a straight angle, if I were to ask you, how do you know that this angle is a straight angle? You tell me it's because it's a straight line or it's because it measures 180 degrees. The second reason, the one that where it says if they told me it measures 180 degrees, or I figured out that it measures 180 degrees, that is the real reason. Just because something looks straight, like if, for example, if they draw a straight line, that doesn't necessarily mean that that's what it's going to be. It could look like it, but it can be a degree off, and that can be very difficult to distinguish. So just be careful with that. Acute angles are easier to spot. Acute angles are just, it's literally any angle that's less than 90 degrees, right? That's pretty much it. It can be any number. I have 45 here because 45 is the most common one. 45 is essentially half of a 90-degree angle, right? But that doesn't mean it's the only one, right? So if 90 degrees is this, right? Any angle that falls inside of it, all those lines could represent angles that are less than 90 degrees. They can all represent potential acute angles of varying size. Notice how I said, keep in mind, it can be any degree as long as it's below 90 and above 0. Obtuse, same thing, except it's the opposite, is any angle that is more than 90 degrees, right? And for the most part, it just has to be less than 180 degrees, right? So if you look at this one looks like it's opened up, right? And by the way, just because my angles are facing a certain way doesn't mean that they are always going to face that way. They can face the other way. The angle, the actual measurement won't change necessarily. Right angles is the only one that is denoted by a different symbol. If you notice on the inside, there it looks like it has a square, right? Like this thing. Whenever an angle has that, it's an immediate indicator to you, the student, that that is 90-degree angle. If you see that little box, there's a 90-degree angle somewhere, and you need to figure out where it is, because that's usually going to tell you that if something is complementary or if it's supplementary, right? That'll be your biggest clue whenever you're doing these problems, right? Because a right angle can only ever be 90 degrees, just like a straight angle can only ever be 180 degrees, which is double, it's two right angles put together, okay? So hopefully you copy this down, pause it if you need to pause it. I'm gonna move on. Okay, complementary versus supplementary, right? So here, if you notice, I have two straight lines, and then I have a 1 and a 2, and I have a 1 and 2, right? If two angles are complementary, like right here, like in the first one, right? If you notice, there's a little box here, right? And that box indicates that that whole angle to the left is 90 degrees. We know that measure angle 1 and 2 are complementary, right? So we know that if we were to add 1 and 2, we're going to get 90 degrees, which is why I wrote an equation, this equation. Measure angle 1 plus measure angle 2 is equal to 90. Now that 1 and 2 are representing the entire angle. They're representing this, and they're representing that, right? Okay, so currently there's no way to know how much 1 and 2 are unless I get more information. So if you notice, the problem continues below. So if measure angle 1 is 50 degrees, so now we know that measure angle 1 equals 50 degrees. So if measure angle 1 is 50, and we know that 1 plus 2 is equal to 90, all I have to do is put in 50 degrees instead of measure angle 1. So if you notice, that's what I did. That's what I did. I'm here, and then I went here. 50 plus measure angle 2 is equal to 90. Now, don't be confused. I cannot add measure angle 2 to 50. I can't do it because measure angle 2 is acting like a variable. It's acting like x, right? And I can't add x to a regular number. However, what I can do is I can isolate x, right? This is an equation after all. So what I'm going to do is I'm going to make sure that the measure angle 2 stays on the left side of the equation. I'm going to subtract 50 to get rid of it because currently it's adding. I'm going to subtract 50. I'm going to get rid of this. And if I subtract 50 from the left side of the equation, I'm going to have to subtract it from the right side of the equation. We're going to go over this more. If you're a little confused, that's okay. But basically, this just means that I end up with a situation where I have measure angle 2, right, is equal to 90 minus 50. And 90 minus 50 is just 40 degrees, which means that measure angle 2 is now 40 degrees. And that's my answer. If measure angle 1 is 50, measure angle 2 has to be 40 degrees. Now, if you notice something here, measure angle 1 and 2 are complementary because they add up and they get 90, sure. The other side is 90, which means that that straight line is 180, which is a straight angle, right? Okay, now let's move on to the supplementary side. The same thing, right? If you notice they're right next to each other, that's not always going to happen, but it's a good starting point. So here, measure angle 1 is a bigger angle, and measure angle 2 is a smaller angle. We're still, since we don't have any squares anywhere, we don't know if there's any 90s. There isn't any 90-degree angles anywhere. But there is a straight line, and the straight line is indicative of 180 degrees, which means that if we add measure angle 1 plus measure angle 2, I'm actually going to get 180 degrees, which is why I started with this formula, this equation here. This equation didn't come out of nowhere. I'm using the rules that I learned and the definition that I learned here to make this equation, and then I'm going to do what I did with the complementary. This problem says if measure angle 1 is 120, then what's measure angle 2? That's the question you're trying to answer. So, according to this, measure angle 1 is 120. So, that would mean 120 plus measure angle 2 is equal to 180 degrees. And likewise, we need to isolate measure angle 2 because measure angle 2 is acting like an x, right? And if we remember from our algebra skills, if we subtract 120 from both sides, they cancel out. But if I subtract 120 from the left side of the equation, I have to subtract it from the right side of the equation. So that leaves 60 degrees. And then this, I just kind of bring it down. Measure angle 2 is equal to 60 degrees. Okay, so measure angle 2 is equal to 60 degrees. I have found my supplementary angle. All right. Okay, finding missing complementary and supplementary angles using equations. We did a little bit of this in the past, but you're going to do this more later on this week. For now, the problem, find the value of x. All right, step 1, identify the type of angle. All right, we have those. Right here, what we have is we have a weird drawing here. Let's start with this drawing. Before we go into any of the steps, this isn't the kind of drawings we're used to, or is it? I mean, we have what appears to be a straight line, and then we have this, our biggest clue. Look at that. Whenever you see that, you want to start there. That means what? It means that the two angles, the angles that we have information for, the one that says x plus 28 and the other one that says 45 degrees, if they're both together like that and they're part of that square, then that means that they add up to 90 degrees. Those are complementary angles. And if they're complementary, I can set up an equation. I can set up an equation just like I set it up here. X plus 28 represents the first angle, right? This angle right here. So I wrote it down, and then I added it to 45 degrees. This one doesn't have an equation. It's just 45 degrees. So I just put plus 45 equals, and I know they're complementary, so they're going to be 90 degrees. Now that I have my equation, right, which is the hard part, I'm just going to solve it. So the x is not compatible with 28 or 45 because 28 and 45 are regular numbers. So the x just comes down to the next step. 28 plus 45 is 73, right? So now I'm left with x plus 73 is equal to 90, right? So now to figure out what x is, well, all I have to do now is get rid of 73. And in order to get rid of it, I have to do the opposite of what it's currently doing. Remember, if it's adding, you do the opposite, which is subtracting. I'm going to subtract 73 from both sides. That's why I cancel it out. And 90 minus 73 is 17, meaning that x is equal to 17. So let's find out if these two, if I plug in 17 for x, will I get a complementary angle, right? Will I get two angles that suddenly add up to 90 degrees? Well, let's find out, right? X plus 28 plus 45. 17 plus 28 plus 45. This is me just checking my work. You don't necessarily have to check your work every time, but it helps if you're confused or you can't get the correct answer. If I add all these together, I really do get 90. Go ahead and put it in your calculator if you don't believe me. But I think if you guys work this out for yourselves, you'll find that yes, those are complementary. I found the missing complementary angle. All right. What if I'm missing a supplementary angle? What do I do? Well, okay. So we're looking here. Like I want your attention here right now, right? All right. So this is a different looking um, shape than we're used to. Yes, it's kind of looks kind of similar. Measure angle 1, measure angle 2, measure angle 3, and measure angle 4. I would pay attention to the given. The given says measure angles 1 is supplementary to measure angle 2 and measure angle 4. What that means is if I were to add measure angle 1 plus measure angle 2, I'm going to get some 180 degrees, right? Because they're supplementary. Supplementary means that two angles add up to equal 180 degrees. So I know that. But what about measure angle 4? Remember, the given says that it is also supplementary to measure angle 4, which means that if I know what one of those is, I can add them together to figure it out. Well, they give you one of the angles. The next line, the next sentence says, if measure angle 1 is equal to 100 degrees, what is measure angle 2 and what is measure angle 4? So that is my problem. I need to figure out how much is measure angle 2 and measure angle 4. Now, you might be thinking, if they're both supplementary and measure angle 1 doesn't change, does that mean that measure angle 4 and measure angle 2 are going to be the same? Well, yes. Here's why. So measure angle 1, we're going to start here, right? Measure angle 1 plus measure angle 2 is equal to 180, right? Because they told us that in the given. I'm going to replace measure angle 1 with what I know, which is 100 degrees, plus measure angle 2 is equal to 180. Then I'm going to figure out what measure angle 2 is by subtracting 100 from both sides. And then this happens to cancel out. And then I'm only left with measure angle 2 is equal to 80, right? And there you go. If this is 100, this has to be 80. Okay, cool. But what about measure angle 4? Well, we're going to end up doing the same thing. Remember, the key here is that they told us that measure angle 1 is already supplementary to those two. And supplementary means if I add them together, I'm going to get 180 degrees every single time. So I'm going to do the exact same thing. Measure angle 1 plus measure angle 4 is equal to 180. Replace the 100, subtract, and that happens. Okay. Now you might be thinking, okay, yeah, I get it. I think so. It sounds easy enough. And then you run into a problem that looks a little like this, right? Um, what if you run into something crazy like this, right? Um, will this even give me a correct answer? Well, obviously I just made this problem up. I don't actually know if it works, but why don't we try it out together and see what happens when we try to do this, right? Actually, I'm gonna change this right here to that. Sorry, I did the math really fast in my head, and I don't think that's gonna work. Let's do that. And let's do that. Okay, so what could x possibly be if both angles are supplementary? So if both angles are supplementary, that means that I should be able to add them together. So I have x plus 70. I'm going to put it in parentheses just so you know the difference, right? But you don't necessarily have to put them in parentheses every time. Plus x plus 10 equals 180. Okay, then. So if it equals 180, right, what do? Well, we have an x and an x on the same side. Remember how I said you can't add x to the regular numbers like 70 and 10? Well, you still can't. But if two x's are there together, you can add them together. Now, when there's no number in front of the x, you're assuming that that's just one x. So what I'm going to do is I'm going to rewrite this as 1x plus 70 plus 1x plus 10. There's always that invisible 1 in front of any variable that doesn't have a number in front of it, right? Because that's to signal that there's one of that variable. In this case, there's two x's because we're going to add them together. And we end up with 2x because there's two x's plus 80 is equal to 180, right? So far, I haven't done anything out of the ordinary. All I've done is added, right? And I've simplified. What do I do now? Well, like the previous problem, I'm going to have to isolate the x. I'm going to have to make sure x is by itself. So what I'm going to do is I'm going to subtract 80 from both sides, right? I haven't done anything with the 2x, so the 2x is just going to come down. 2x is equal to 100. Okay, we're getting there. Now, when there's a number in front of the x like this, it's multiplying. 2 times x is equal to 100. That's really what it's saying. Now, in order to isolate it, in order to get rid of the 2 times, I have to do the opposite of multiplication, which is division. I'm going to have to divide both sides by 2. That leaves me with x is equal to 50 degrees. We know that x is 50, but that doesn't tell us how much each angle is, right? Let's say this is measure angle 1 is equal to that, and this is measure angle 2, right? If I wanted to find out how much measure angle 1 is, I'm going to have to take x is equal to 50 and plug that back in, meaning measure angle 1 is equal to 50 plus 70. Measure angle 1 is 120 degrees. Okay. Now, I could figure out what measure angle 2 is the same way, or I could just subtract from 180. I could take 180 because I know that's how much the total is, minus, right, 120, I'm going to get 60, or I can do it the other way where I can just plug in measure angle 2 is equal to x plus 10 is equal to, or I could do it the way I just did the other one. So this ends up being 120 and this ends up being 60. And I have just figured it out. Okay, these are the types of problems you are expected to do, right? I will be posting each page every single day that you are doing. Again, the practice problems are due at the end of the week, but don't let them pile up. Talk to me if I'm at your site. Talk to a teacher, whoever's helping you out. Watch this video over. Feel free to email me. If you guys need to email me for any reason, right? Here's my email. Okay, that's laedcorps.org. And that's it for today. Hope you make sure you write all these notes down on a separate piece of paper. Take a picture of them, and you're going to upload them onto Google Classroom. Even if you see me in person, you're still going to have to do this process, because if we are forced into another quarantine where we're not allowed to go to site and you have to continue online, then everything will be online. So we might as well just have everything online to begin with, even if you are going to site to get help. All right, that's it. Thank you.